Hello. In this lecture, we will study the grammar. So, first we will discuss uh, what is basically a grammar, and we'll give a definition of a grammar. So, a grammar can be a grammar a grammar can be defined as four tuples. Four tuples. What are these tuples? So, P of n, sigma, P, and S. What is the V of n means? Non-terminals. Sigma is the terminals, P is production rules, and S is the start symbol. Where Bn is basically finite, non-empty, empty set of variables or non-terminals. Non-terminal. Right? Now, what is sigma? Sigma is a finite, non-empty set of input alphabet or terminals. Now, what is S? S is the start symbol, and basically S belongs to the non-terminal V of n. So that is an element of Vn, and P is a finite finite set of production rule set of production rules. Okay. And now V of n means non-terminal set, finite set of non-terminals. If we take intersection with finite set of finite non-empty set of input alphabet or terminals, it should be always empty. Yeah. That means Vn and sigma have no common elements. Now P is a production rule. So P is a finite set whose production or whose elements are alpha to beta. So P is a finite set is of that form alpha to beta, where alpha and beta are string on Vn union sigma. That means this alpha and beta basically constitutes by the non-terminals as well as the terminals, and alpha has at least one symbol from Vn. That means alpha and beta both are strings on Vn union sigma. That means alpha and sigma will construct by using this terminal as well as non-terminal. But alpha has at least one symbol from these non-terminals. And now the language that is generated by the grammar is basically set of all strings of terminals. So how we can define? Uh, so if if G is the grammar, G is the grammar, and obviously L of G is language generated by this grammar G, and if G is defined by these symbols then sigma, P and S, then we can write that language generated by this grammar is basically, we can read also like that, generated language generated by grammar G. It means set of all terminals terminal string represented by start symbols, by start symbol S. That means all the terminal strings which are basically represented only by the start symbols will be the language that is basically generated by the grammar G. And in every production rule there is a start symbol S. In case if this start symbol S is missing, at the time the left hand side of the first production is considered as the start symbol. Now generally capital, that means A, B, C, A1 means, we can also not write like that, clear? A, B, C, uh, Z, etc. are basically considered as a non-terminal or variable. Non-terminal or variable. Small a, small b, small c, small z are basically considered as a terminal. Are basically considered as a terminal. Right? These are variables, terminals. Similarly, x, y, z and alpha, beta, suppose gamma, we call these are basically the element elements of Vn union sigma S star. Clear? Now, for example, suppose a production rule is given like that. A production rule given this form, like suppose A to small a, B to B, A or capital C. Now how we read this? So here it means A to small a. It is a terminal. Look here, left hand side it is a variable. So the form is alpha to beta, right? And alpha here both are variable here. A and B both are basically the variable. Here on the right hand side A is a terminal. Here it is a both, it is a combination of terminal because beta is a combination of terminal as well as non-terminal. Here it is a non-terminal. So we can say it means A to small a and it means B to BA and B to C. B to C. Right? So now we'll give another example. Suppose Suppose, uh, example 1, suppose there is a grammar G defined on four tuples Pn, sigma, uh, production rule and the start symbol S, where V of n is given as a start symbol S, right, and sigma is basically given AB, right, and production rules. So obviously S is the start symbol and production rules are given this. We can write in this way: production rules. Production rules are given in this form: S to A S B and S to A B. So these are the production rules that is basically given. So here this uh, S is the start symbol. So two rules are given. So now S to A S B and S to A B. So uh, if if alpha and beta are strings on Vn union sigma. Now what is Vn union sigma here? Vn union sigma is basically non-terminal, only non-terminal symbol is S and terminal symbol is A as well as B. It is a non-terminal symbol, right? So Vn union sigma is basically this. Now if alpha and beta are strings on Vn union sigma, so we can write this notation: alpha derives beta, right? So it means alpha derives beta, okay, and this star means more than one substitution and G means by the application of the grammar. So overall alpha derives beta by using the grammar G and more than one substitution are applied to derive beta. Clear? So this is basically the meaning. Now we give another example. Suppose we are given V of n is equal to, means non-terminal. There is a no, there is a two non-terminal symbols S A. Sigma is given A B and production rules given P is like that, or you can also write in that form. P basically given S to A B, then A to A B or A to epsilon, right? So these are the three production rules are given. So now here start symbol is obviously S. Clear? So the start symbol is obviously S. Now uh, from this here, what is the language generated by this grammar? So what will be L of G? This is my question. Uh, what will be the language that is generated by this grammar? Clear? So to generate the language, we try to find a pattern. So how we can find the pattern of the language? So look here, from start symbol, we have to generate all the terminal strings that are basically generated, and that will be the set in the language. This is basically this set of strings are basically the language generated by this grammar. Now from this production rule, if we put A into here, so from S, suppose S is there, so for the production from this, if we write A B, because from S this will be generated S to A B. Now if we put this A equal to epsilon here, so from here it will be AB. So the smallest string that is generated from S is AB, right? Now So the smallest string is AB. We have generated now multiple substitution if we applied. Suppose A's drives A, here it is a one step derivation. Now if we replace this A by this production rule, A can be replaced by A, B. So we can write A and this A will be replaced by A, B. It is a two-step derivation. Similarly, three-step derivation will be A, then again A, then B. That is basically this A are every time substituted by this A, B. Okay. Now, if we perform this up to n step derivation, what will happen? So, if we do this for the n step derivation, it will be look like that A to the power n, because same number of A followed by same number of B. So we call it is basically the n step derivation, right? Now what we have seen that the smallest string that is basically generated by this grammar is AB, and the pattern is basically A to the power n, B to the power n. Yeah. So we can say that the from start symbol, by application of the grammar G that is defined by any number of substitution or more than one substitution, we find this pattern. Okay. Now if it is a form A, suppose A, B, so this is basically called the sentential form. Sentential form. And A to the power n, B to the power n basically called the sentence. Okay. So the language basically generated by this grammar is L of G is A to the power n, B to the power n. Now, what will be the value of n? Because we have seen that the smallest string that is generated by this language grammar is AB. So the n should be greater than or equal to 1. So this is our final answer, that language generated by the grammar is this. And it is a sentential form and it is called the sentence. Now, what happened? What happened if the production rules are slightly changed? For example, uh, suppose the production rule is given like that. If we change P, suppose P equal to defined as S2 ASB comma S2 small epsilon. Look here, the smallest string that is generated by this production rule, all other symbols remain same, is epsilon. So from S, it derives epsilon, and from S, first step derivation will be ASB, second step will be AASBB. So in this way, if we do, then the pattern will be like that: A to the power n, B to the power n. Now, what will be the language generated by this grammar now? Because basically by this production rule, all other symbols remain same. So here the language generated by this grammar will be A to the power n, B to the power n, but now the value of n should be greater than or equal to 0, because it generates a string of length 0, that is n should start from 0. In the previous case, n should start from 1, because the smallest string that is generated by this grammar, it was basically AB. That's why we have written n greater than equal to 1. But now the smallest string that is generated by this grammar is epsilon, so n should be greater than or equal to 0. Now we define language generated by this grammar. Uh, so language generated by this grammar is formally we can define by using this is that S belongs to sigma star, because basically this string should be only by using the terminal symbols, and from start symbol S by any number of substitution with the grammar G, it will generate this. Clear? This S is the terminal. So here S is basically a string formed by the element only from this uh, terminal symbols or the input symbols, and here S is the extra symbol. So now the element of LG are called sentence. Okay. Now if S derives alpha by any number of substitution by the grammar G, the alpha is called sentential form. Sentential form. Note, the element of LG are also sentential form, but not vice versa. Clear? The element of LG also we called that it is a sentential form. But sentential form means it is not a sentence. Okay. Now we'll give another example. Suppose we are given, suppose we are given example suppose 3, we are given a grammar like this: G equal to start Vn is this, terminal is AB, production rule and S, where P is defined like that: S to small a, S to small b, S to a s, S to b s. So now if we want to find what is the language that is generated by this grammar is, here the what are the smallest string that is generated by this grammar. So we can write in this form. So A, B, and now if we put S here, that will be AB. If we put B, and in this case, if we put A instead of B, so it will be BA. And if we put here A again, then it will be AA, BB, and so on. These are the basically pattern. So it is basically all the strings by the combination of AB except epsilon, right? So all strings having the any combination of A and B, but only the string, that empty string, is missing here. So we can write that language generated by this grammar is basically A or B plus, means without epsilon. Okay, we'll give another example. Suppose we have given example, suppose or exercise suppose 4. Now suppose we have given some production rules of this form. Clear? S2 0, S1 1, or epsilon or null. So now we have to find the language generated by this grammar. What will be the language? Here all other symbols remain same. Here S is the start symbol and 0 and 1 is the terminal here. Clear? Here sigma is basically 0 and 1. So again, so S derives, look here, epsilon. So the smallest string that will be generated by S is epsilon. Clear? And S derives 0, S 1 1. The one step derivation. Now if we put this instead of S we put 0, again S 1 1 1 1, and so on. So it is basically is of the form, right, 0 to the power n, and S can be replaced by epsilon, so 1 1 to the power n, or also we can write it in that form 0 to the power n, 1 to the power 2n. Okay. Now, so the language it will be So the language generated by this grammar will be 0 to the power n, 1 to the power 2n. What will be the value of n now? N should be greater than or equal to 0 because epsilon is another string that will be generated by this grammar. So if we put 0 here, it will generate epsilon. If we put 1, it will generate 0, 1, 1, clear, and so on. So this is basically the language generated by this grammar. Now we'll give another example. Yeah. Now, reverse processes. Suppose we have to find question, find the grammar. Find the grammar generated by generated the language generated, find the grammar generated the language L of G is of the form a to the power n b a to the power n such that n greater than or equal to 1. So we need to find what will be the grammar for this language, right? So obviously look, same number of to solve this, the strings pattern will be like this. First n is greater than or equal to 1. If we put 1, it will be a b a. So the smallest string that will be generated by this grammar language will be a b a. Then it will be a b a. So look here, only one b will be there, and on the left, before left of b and right of b, same number of a. That means same number of a followed by a single b, then same number of a. Okay, the pattern would be like this. So how we can write the grammars? Grammar means actually you have to write the production rule first. So what will be the production rule? Look here, uh, it will be like that we start from here. So s can generate s is a, right? So if only this given, then it can generate a to the power n and a to the power n, clear? And also s could be written in that way, a b a, clear? Also so these two things will basically generate this. How? Look here, suppose we want to generate this string a b a. So first we will start from here, s to a s a, right? S to a s a, and then we replace this s by a b a. So a b a. So you generate this, right? So this sentence of a b a generated. So we can give precise answer like that. The answer will be, the grammar will be G, where Vn, sigma, Pn are the four tuples, where V of n is basically a single symbol S, and terminal will be AB, and whose production rules is basically S to ASA or S to ABA, and okay, these are basically where S is the start symbol. Start symbol. Okay. So this is basically the grammar for the language a to the power n b a to the power n. Now, we'll give another uh, example. Suppose, suppose uh, we are given the language is of the form. Language is of the form. So language is this W small c and W transpose, where W belongs to A, B, and its star, right? That means W is basically construction of any combination of AB, right? And W T is basically transpose of W. So what will be the basically production rules for this to generate this grammar? So from here we have to generate the grammar. So now W basically belongs to this because it is a combination of AB. It can be epsilon, it can be only A, it can be only B, it can be only AA, it can be only BB, it can be AB, it can be BA, and uh, it can be B and A and so on. So this is basically pattern. Like now, first is in this language what will happen. So in this language, if we put epsilon, then it will be only C, and if we put A, then it will be A C A. If we put only B, it will be B C B, right? If we put AA, so it will be AAC, AA. If we put AB, BB also there, BBC, BB. If we put AB, then it will be ABC, then BA. Reverse. Here it is a reverse. If we said AB, then BA. If we put BA, then BA, then C, then AB, and so on. So these are basically the language for this. Now we have to generate a grammar that will generate all these strings. So what is the smallest string that is generated? Is obviously small c. C is also a terminal here. Consider C is a terminal. Okay. Now what will be the production rule? So S obviously generates C, smallest string. Or S can be right in that way. Look, C, same symbols are there. Every time when C before that AA, if B then it will be BB, here BB, here also AA. That means the production will be like that. A, if there is a then we can write ASA, or another way, if there is a B, then we have to write BSB. Right? Now, if we want to suppose, these are basically the production rule for the grammar. Okay, these are the production rule for the grammar. Now, suppose we want to generate this string. How? From S, we can write, look here, we have to start from where? Where we have to start, because BACAB will be generated. So we have to start from here because we have to replace the S only. So we can write B S B. Now with this S will be replaced by A S A. So we can write B, then A S A B. Now we replace this A by only C. So B A C A B. So this is the string, terminal string that is generated from this grammar. So our resulted grammar is this. So we can write the grammar G is equal to Vn sigma Ps, where V of n is equal to a single symbol, that is S, and sigma is basically we can write A, B, C, and production rule is defined here, and S is the start symbol. Okay, so we have given few examples related to this. Thank you.